My name is Daniel O'Connell, and for the past 6 weeks I've been working with Amnesty International to try and answer the question, can machine learning help death penalty monitoring? So Amnesty International are a non-governmental organization that are concerned with the preservation of human rights worldwide. So some of the areas they involve themselves in, for example, are women's rights, the ending of torture, and the abolition of the death penalty. So in the United Kingdom, the death penalty was abolished in 1965, but worldwide there are still 54 countries that actively engage in capital punishment. Sometimes for offences as relatively minor as drug possession. Legislation like that can lead to the death of, for example, in Iran last year, upwards of 500 people. And very often, governments are quite suppressive about releasing information about executions. For example, in China, where thousands of people have been estimated to have been killed last year, news about capital punishment is a closely guarded state secret. So where did these figures come from? Well, they're compiled by Amnesty International volunteers. And a big part of that process is media monitoring. So keeping tabs on news outlets around the world for information about death sentences and executions. This is how that process works. So here are our 3 Amnesty International volunteers. And these symbols on the left here will represent news on death sentences and executions that's available online. It's the job of all of the volunteers to individually access, process that information for things such as the country, the names, and the context of the events, and then archive that information into their own database. So there's a few problems with that approach. First of all, it's quite open to redundancy. So every time that a line crossed in the previous figure, that represented a time when 2 volunteers were looking at the same article, which is not really necessary. It's very slow, and it's quite tedious. And it's limited by the language of the volunteer themselves. People can only read articles in languages they can understand, of course. So a more efficient approach would be to implement a machine learning algorithm that can automatically access, process, and archive that data on behalf of the volunteers. So my project was to build this machine learning algorithm. And it works by emulating what the volunteers are already doing. So the first thing it does is it has to get the news articles themselves. That's pretty straightforward. I use a service called WebHose, which will take a search query. So I'll use as an example sentence to death, and return a set of unorganized news articles related to that query. The next thing that the algorithm has to do is it has to read those articles. Now, something that's a little bit more difficult to teach a machine to do. So the way I tackle that problem is I tell the machine to determine the important words of the article. So here's an example about Noura Hussein. That's a Sudanese woman who recently had her death sentence overturned. And here are the words that the article has determined are the most important. So we have, for example, appeals, overturned, Sudan, the hashtag there, justice for Noura, and Noura Hussein, the name of the defendant herself. Once we've determined which words are the most important in the articles, it's fairly trivial to find out which articles are referencing the same event, which I've shown here in different color groups. Once that's done, they can be partitioned into different clusters, and then we can use natural language processing techniques to find out which article of each cluster contains the most information. And it's those articles that are subject to an extraction of that information. That's done by making a comparison to all of the articles that Amnesty have previously archived. From that, we can determine information such as the country and the theme. So in keeping with the example of earlier, I was able to predict with an 86% confidence level that the country that was mentioned in the article was Sudan, and that the theme of the article was an exoneration. So theme in this context, by the way, means whether the article is referencing an exoneration, a new death sentence, an execution, a commutation, etc. When the comparisons have been made, I use more advanced natural language processing techniques to figure out what the names are in the articles. So keeping with the example, Noura Hussein features quite prominently. Once the information has been extracted, the only thing left to do is to archive it, and it's actually put back into the original database so that that can be used to refine future predictions. The advantages of using a method like that are that it's automated. All that's required is a search term, and the algorithm will do everything else for you. It's fast. To process 1,000 articles takes just shy of 5 minutes. It's efficient, and it frees up time for the volunteers to focus on other tasks, and it can be used in multiple languages. All that's required is a search term in, for example, Arabic. The results will then be returned in Arabic. They can be machine translated and pushed through the exact same analysis pipeline. So how well does it work? Well, I tested the algorithm against the death penalty monitoring team at Amnesty, and it was able to detect almost 80% of the new executions that they themselves archived for a week-long period. Or to put it alternatively, the work of 4 volunteers could be reduced with the implementation of this algorithm to the work of 1 volunteer who has to catch the 21% that the algorithm misses and verify the results of the algorithm itself. So in summary, I've written a machine learning algorithm that can automatically access, process, and archive news about a given topic. For this example, it was the death penalty. That has the effect of boosting productivity for the death penalty monitoring team and freeing up time for the volunteers so that Amnesty can better direct their limited resources. Thank you very much.